Hello, in this video, we finalize the urea handling part of the AdBlue system. I'll add a urea hopper with a double screw conveyor, adjust filling nozzles based on the 3D model, and show one simple but very useful trick to precisely place nozzles in your layout. Now let's insert our hopper into the model. You can also create this equipment yourself. Simply build a hopper-type tank using solids, then add 2 cylinders and rotate them at a 45-degree angle to represent the screw outlets. In our case, the most important part is the filling nozzles connected to the reactor. The remaining elements are added mainly for visualization and layout clarity, not for detailed manufacturing. Our hopper is created as a block, so I'll enter block editing mode. Inside the block, I adjust and extend the screw conveyors so they reach the reactor top nozzles. This approach lets us fine-tune the geometry directly in place, ensuring proper alignment with the reactor while keeping the overall equipment structure unchanged. Here I'm extending the screws in a rather simple, even primitive way. The goal is not perfect modeling, but to demonstrate the method I personally use to match equipment and nozzle positions in the layout. This approach is fast, practical, and works very well when the exact geometry is less important than correct alignment. Our level column is positioned incorrectly under the screws, so I relocate it. This is exactly the type of issue that must be solved during the project and modeling phase, not after the tanks and equipment are already manufactured and installed on site. Fixing these conflicts early saves time, money, and prevents serious problems during construction. And especially the engineers' nerves during construction. Resolving these issues early in the project phase avoids unnecessary stress, on-site improvisation, and last-minute design changes when everything is already in place. Now we connect the reactor nozzles to the screws. Here the size difference and nozzle location become immediately visible. I adjust the nozzle size and shift the hopper sideways and forward. And now adjusting heights. One nozzle already fits perfectly. For the second nozzle, I want to show you a simple but very effective trick. First, I create an orthographic view of the reactor and screw hopper. In this view, we can perfectly measure distances without perspective distortion, which makes positioning fast and accurate. In this top view, I can measure the distance from the center and the angle relative to the vertical axis. Using these 2 values, I can place the second nozzle on the reactor very accurately without any guessing. I can simply copy the nozzle and offset it a few millimeters to the side. The nozzle position must be defined by an exact distance from the center line and a precise angle. I measure these dimensions directly here in the orthographic view. To measure the angle, I first create a few construction lines. These lines cross the center of the reactor and the center of the screw outlet. Using these reference lines, I can measure the angle accurately. Sometimes, it's not easy to catch the exact center point. One important thing to notice: if you draw additional lines in the orthographic view and then add dimensions, you need to pay close attention to what you are snapping to. If your cursor snaps to the lines you drew in the layout, the measurement will be taken from the layout, not from the model space. This is exactly what happens here. You can see a value of 20, which is incorrect. If you want to measure real model geometry, you must snap directly to objects from the model space. So here I make sure to catch the model lines, not the layout annotations. How do you notice that a measurement is wrong? Usually, it's obvious from experience. If you are measuring a tank and you know its real size is not 20 or 50 millimeters, but closer to 5,000 millimeters, the mistake becomes clear immediately. When the numbers don't make physical sense, it's a good indication that something is wrong with the measurement. And these measurements are not really wrong. They appear wrong because orthographic drawings are created using a scale. You can think of the layout as a sheet of paper, and the model space as a window placed on that paper. That window is shown in a specific scale, for example 1 to 100. When you dimension layout geometry, AutoCAD measures it without applying the model scale. That's why the numbers look incorrect. So now, back in the 3D model, we already have the angle and the distance from the center. With these values, we can place the nozzle accurately. Now I just measure the height difference and adjust nozzle height. And it looks like the plan worked perfectly. Here you can see the complete AdBlue system with the urea conveyors. One more 3D element here, the urea big bags. It looks like we have plenty of free space, unlike real project sites, where free space is almost a miracle. We have to remember that big bags are not handled by hand, but by a wheel loader or a forklift. This equipment needs additional space for turning, around 3.6 meters or more. So we always have to leave enough space for the loader path. One more important point about the hopper. We need access to the top of the bin for maintenance, for example, to remove urea lumps if they occur. That's why I add maintenance platforms on both sides of the hopper. This is just to visualize how it looks. Thanks for watching. Subscribe, and see you in the next one.